Okay, so let's take a look at the TCP IP stack and its role in networking communication. So let's say you are on your computer and you want to watch a movie today. So you go on to Netflix. And how would you do that? How would you get a movie from Netflix? Well, you could go onto the Google Chrome app on your computer and type in Netflix. So what's actually going to happen for you, right? You're a user to get your show from Netflix. Now, Netflix is going to be somewhere else, right? In another network. So this is a server and you are in your network and Netflix are in their network. Well, you can use TCP IP communication. So what's going to happen? Step one is going to be your application is going to construct an application level packet. Okay, so Google Chrome in this case is your application, and it's going to construct a packet like this, which is going to contain your host and where you want to get your data from, amongst other information. But very importantly, the application protocol that's going to be used. And in this case, it's HTTP as your application layer protocol. Now remember, an application is simply just a piece of software on your computer. So other applications could include a YouTube app that you download or some games that you download. So now that we have constructed our application layer packet, how are we actually going to send that? Now remember, to send something from our computer, we need to go through the hardware here. But we can't, as an application, Google Chrome cannot just directly control the hardware. It needs to go through an intermediate application. And we know what that is. This software is the operating system. So for your applications on your computer to use the hardware, they must seek permission and go through the operating system before we can send our packet, our request to Netflix, and then for Netflix to send our movie back to us. So we need to then go to the transport layer, which is going to be a transport layer packet constructed by the operating system. So the operating system is going to take our application layer packet and add some stuff to it. It's going to add specifically the ports and the sequence number. Okay, now we only have one packet here with sequence number 1, but we could have taken our entire application layer packet and split it into many packets and send that. So we need to uniquely identify each packet with a sequence number. But in this case, we didn't. So the destination port is going to be the destination application layer protocol. So we're using the application layer protocol as HTTP, which means the destination port has to be 443. So when Netflix receives the port number, it knows, this was a HTTP request, and it's going to handle that appropriately. So that is our destination port. And the source port is going to be the port number that the operating system assigns our application. So the operating system is going to say, okay, Chrome, you can have this port number, 54321, right? Maybe Games has another port number like 171 as an example. So now we are adding the port number to the source port number. So when we get a response back from Netflix, we know where to give it to. We don't want to give it to Games, the response. We want to give it to Chrome with port number 54321. But we're not done. We have now just done the application layer here, right? And we've done the transport. Now we need to do the network layer. Now the network layer is going to take our transport layer packet, which already contained our application layer packet, and add even more information to it. So it's going to add the IP addresses and the source and destination IP address. So how is it going to get the IP address of Netflix, which has IP address 40.0.0.0, and we have IP address 27.0.0.0. Okay, how is the operating system going to get Netflix's IP? Because we already know our own IP. Well, it's going to do what's called a DNS lookup. And it's going to put in Netflix.com. It's going to take the domain name, okay, and output the IP address. So the operating system will handle taking Netflix.com, which is what you typed on your Google Chrome browser, and it's going to perform a DNS lookup and translate that into the IP address of Netflix, which is this. So we've now added the destination and source IP address to our packet. And this was done at the network layer. And the final layer is going to be the link layer, okay? And the link layer is going to take our network layer packet, which contained our transport layer packet, which contained our application layer packet. So remember, we're stacking these on top of each other. And the network layer, the link layer is going to be responsible for adding our MAC addresses, our source and destination MAC addresses, which are unique identifiers for each device. So we have a MAC address here, which is going to be our source, right? It's going to be a long number and it's going to look something like this, but I'm not going to write it because it's very long. So our device is the source device because we're the ones sending. So we add the source MAC address. Now, unlike the destination IP, we do not know the MAC address of Netflix. There is no DNS for MAC. So the destination MAC address is not Netflix, but it's the place we're going to next. So what router are we going to go to next? So in our network, we have, say, our home router. Then we have a router in between. And then we have the Netflix router. We are going to want the destination to be the MAC of R1. So that is our destination address. And to make this clearer, our source MAC address is going to be the MAC of dev for device. And the operating system is going to know that. The operating system is going to know, okay, we are sending our packet to a server outside of our network, to a device outside of our network. And to get out of our network, we have to go all the way to our router first. That's first point of contact. And then we can travel outside of our network to get to Netflix. So the operating system is going to know the MAC address of the router R1, which is what we add here. So we have finally added our link layer data, and we have gone down from application down our TCP IP stack. And now once we've done that, once we've gone down our TCP IP stack all the way to the link layer, we can physically leave our device. The packets can leave our device through the NIC. So either by Ethernet or by radio waves. So if we have our computer here, and just to be clear that this diagram here is simply what's going on inside our device. So our NIC is a piece of hardware in our device. and we want to send our newly constructed packets to the router, if we had an Ethernet cable connecting our computer to the router, what we could do is we could send our packets through the Ethernet cable as such. Now, we may not have an Ethernet cable connecting our computer, so we can then send our packets to the router via radio waves. And this will allow us to leave our device and go to the router, and then the packets can travel all the way to Netflix. Okay, so now let's take a look at what's going on inside our packets when they're traveling from our computer A all through the network to then Netflix at computer or server B. So let's take a look at the route. Okay, so remember, now that we've constructed our packet in the final form, which includes the link layer data, such as the physical MAC addresses, what's going to happen here? Okay, so the data, of course, starts at A, and it's going to leave our hardware on our computer, the NIC, and go to R1. So we can write that as A goes to R1. Now, what is the source MAC address in this packet? So if we take a look at our packet, which is this, it includes all of our data from the application layer to the transport layer, to the network layer, to the link layer. What does the source MAC address going to be? So it's, of course, the MAC address of A. It's this, MAC A. And what's the destination MAC address? Well, it's the MAC address of R1, right? Because we're going from A to R1. But this router here now needs to change the link layer data. So it's going to take the link layer packet and see, at this router, it will see this. Source A, destination itself, R1. So A is S for source, destination is R1. This is the link level data that R1 will see. But it now needs to change the destination to what? What do you think? Well, R2, of course. But how is it going to know to do R2? Well, that's where it's going to not just look at the link layer data, but the network layer data. So it's going to say, okay, let's open up the network part of the packet now and see the source IP. So this is IP, so this is the IP of A, and the destination IP, which is the IP, remember, of Netflix. So IP of B, not the next router. So R1 is going to say, okay, so we need to get to IPB. And then it's going to go, to get there, we need to, of course, go to R2. So the router will know what next router it needs to go to in order to get to the destination. And then R1 is going to now change the link layer data. So it's going to say, okay, let me cancel out this. And now the source MAC address is going to be R1, and the destination MAC address is going to be R2. And then R1 can forward that new packet and say, right, let's forward that new packet along this to R2. Same packet, but now different source and destination. So this path is going to be R1 goes to R2, the source is R1, and the destination is R2. And if you're wondering what these lines are between routers, they are cables, and in the real world, they are underground. So if you have your house here, and you've got a router in your house, and you want to send to someone else's house here, and they've got a router, there will be places where there are routers as well in between, and your position at B will go, there will be a cable at your router connecting to another cable at another router, and then another, and then another. So your packets do travel through physical cables connected. Okay? So that is what's going on underground. And you may have heard of fiber optic as an example of a cable. But now let's go at R2. So at R2, we want to go to R3. Again, R2 is going to look at the network packet and go, okay, we need to get to the destination, so we must go to R3. So R2 to R3, the packet at this point here, going that way, is going to have a source MAC address of R2 because it starts here. It's going to have a destination MAC address is R3 here. And then finally, once we're at R3, R3 will know we need to get to the device, so we have to go to B. So R3 to device B, we need to go from R3 to MAC address to the device with MAC address B. So remember, we are looking at the network level packet to know what router to go to, but we are changing and editing this stuff which corresponds to the link layer information, the source MAC and the destination MAC address. And finally, let's take a look at what happens when the packet has arrived at the device. So we previously seen, we went from device A, we went from router to router, and then our packets arrived at device B, but now it's at B, what's happened? So what that looks like is our packet started at the link layer because, well, it was sent with the link layer data because we went down our TCP IP stack. So from application to transport to network to link. And it will arrive at Netflix's server at the physical hardware, remember? Which means we now need to go up the TCP IP stack, going from link to network to transport to the application. And so how that will look is we come in here, the packet comes here, and the link layer looks like this. The operating system sees we are at the MAC address of device B now, okay? Then it's going to see the network layer should be this. The network layer details, which is the IP address of device B. So remember, this is device B, this is device A, and these is what's going on inside each device. And then let's go back to the transport layer. So let's go up the TCP IP stack, and it can see port number 443. So the operating system goes, okay, I need to now provide this packet to the application with port 443, which is this application, which could be Netflix's processing, HTTP processing service. And then we can see inside the application what is specifically needed. So it's videos there, which means the user we ask for videos. And now Netflix knows, okay, the user asked for videos, and now I can send the data back to the client. And to do that, we now need to go down the TCP IP stack. And then on the client side, we need to go up the TCP IP stack. So when sending data, we go down the stack, and when receiving data, we go up the stack.